Hey guys, welcome. Yeah, so Jesus Christ is God, and this is a fun geometry problem. Yeah, okay, cool. Now yeah, so the task is to find the shaded area here, which is like some cool, like, yeah, whatever shape that is. And I shouldn't have to, like, you know, summarize or say anything that is clearly visible in the visual, which is, for example, that the four circles are of equal radius and that they're internally tangent to the larger circle, blah blah blah. You can see that clearly. Yeah, so the large circle has radius 2 and each of the smaller circles has radius 1, and again the task is to find the area of the shaded region. So the most crucial piece to solving this problem is figuring out this area here. Yeah, notice that this area here is the same as this little strip here. Yeah, okay, now this is vital to our strategy and finding this area here. And let's do it this way, which is like, if I cut it into 2, right? If I did a better job cutting it into 2, it looks something like this. So this area we can find easily, and then we can double it. And this is how we can find this area easily. Well, if I, like, you know, made a quarter circle right here, right? Then what we could do is, right angle right there, what we could do is, you know, find the area of this quarter circle, all of it, and then take out the area of this isosceles right triangle. Now, since each of the small circles has radius 1, the area of the quarter circle would be pi over 4, right? Okay, and from it I want to subtract the area of this isosceles right triangle whose two legs have each measure 1. So that's 1/2 by the area of triangle formula, base, which is 1, height 1. It's an isosceles right triangle where, again, the radius is the leg of that isosceles right triangle. Yeah, so this just says pi over 4 minus 1/2. Okay, cool, cool, cool. This is progress. Now, pi over 4 minus 1/2 is this shaded area, which is half of the area of interest, right? And so we just have to double this to get now that shaded area, which again is this little strip that is of great interest. And so you see, when I multiply by 2, I'm going to get pi over 2 minus 1. Ah, cool. So don't need you anymore. But yeah, this little strip of area right here, we've just figured out is equal to, sorry guys, like, it's equal to pi over 2 minus 1. So pi over 2 minus 1. Nice. Okay, where to next? Well, where else? Well, we have to figure out, right? Now, well, we have to figure out the shaded region. I'm going to break into 2 tasks in the remainder of this video. One is, let's figure out the area of the shaded region of interest contained in this small circle at the top, right? So meaning, like, all of this except for this little strip. Wait. The area of one of the small circles is pi r squared, which is pi times 1 squared, and so that's just pi. And so from the area of one of the small circles, what we want to do is take out this little strip, and that will give me this area right here, the shaded area of interest, but only that which is contained in this small circle at the top. Yeah? Yeah, you get it? Okay. I'll do better. So this is the area we're trying to figure out. Right? And I'm saying this area, which is now, what do they call them? Like the breakfast thingies, like that you put syrup on. What do they call them? Whatever. Okay, it's one of those. So that's what we're after. This thing, pancake. No, it's not a pancake. It's a waffle. I think so. Anyway, yeah. So now what we want to do is, for our shaded area, like, totally tangent there. We want to find the area of the waffle plus this little strip that has, like, a cool shape to it, right? And so that will be like the area of the shaded region that we're after. So for the waffle, what I'm saying is we could do the area of one of the small circles minus this little strip, and we already found the area of that little strip. As I said, the area of one of the smaller circles is pi, and so we go pi minus and then it's pi over 2 minus 1. So that's pi minus pi over 2, which is pi over 2, and then minus 1 is plus 1. Ah, cool. So waffle has area equal to pi over 2 plus 1. Cool. So the last thing remaining is to add to the area of waffle the area of this little fella here. That's like really cool in design, right? This fella here. Ah, sorry guys. It seems like I'm being really silly, like shading this, but like it's actually like intentional. Not the intention is not to annoy you. It's like, okay, I wanted to darken it because look, where else do we have that little strip? We have it here, here, here. Now we want to simplify our work, so I don't want to go down there. So what I'm going to do is I'm going to like make a semicircle. Well, 2 semicircles obviously, but out of the big original circle, and concern myself with the upper half. So you see the upper half of the big circle has area equal to pi r squared over 2, but r is 2 here, so pi 2 squared over 2, so that's 2 pi. So this is the area of the upper half of the big circle, right? That's 2 pi. Okay, so what do I want to do from here? Well, from here, what I want to do is I want to tell you that this little fella here, this here has area 1. And this here has area 1. If you don't know what I'm talking about like if you take the small circle and then cut it in half, so take half of the small circle and you subtract this little strip that was of interest originally, what you get is 1, because, well, the semicircle here, the small semicircle, has area pi divided by 2, or pi over 2. So if this little strip is pi over 2 minus 1, it must mean that the unshaded part of this semicircle that's, you know, outside of this little strip must have area 1, because obviously 1 plus pi over 2 minus 1 makes pi over 2, which is exactly the area of this semicircle right here. You follow what I'm saying? Okay, cool. So this has area 1 and this has area 1. Ah, so that means that the portion that I shaded, you know, in white, that has got to be, well, it's got to be this semicircle, the big semicircle, which has area 2 pi, minus this small circle, and then minus this fella divided by 2. You follow? You follow? You follow? So I'm saying this shaded white portion, the nice design over here, well, if we just like for now like also count this, if we call this part A, this nice design, well, this guy is also A. So what I'm saying is, like, in other words, what I'm saying is that 2A is equal to 2 pi, which is this big semicircle, right, top half of the big original circle, minus pi, which is the area of this small circle here, and then minus this little part, and I'll highlight the little part that I said has area 1, and that's this, and then minus this little part, right, which also has area 1. Yeah? Okay, so 2 pi minus the small circle minus 1, and then minus another 1. So 2a then, where a again is this little strip that has a nice design, 2a is equal to, well, this is pi minus 2. Ah, cool. So then a must be pi minus 2 divided by 2. So that's pi over 2 minus 1. Now remember, we already figured out the area of waffle. So to find the area of the shaded region of interest, all we have to do is add to waffle a. But where was waffle? Waffle area is right here. So if we add a to it, we add pi over 2 minus 1. And so pi over 2 plus pi over 2 makes pi. Plus 1 minus 1 makes nada. So